to a new problem today. So yeah, this one has attracted my interest. I've just spotted it, and I thought I'd do a stream pretty much immediately because I think it's a really cool problem. So the idea is to rotate a grid by 90 degrees clockwise. And there's a constraint on here where we are not allowed to allocate another 2D matrix and do the rotation because, yeah, I guess it's trying to simulate a scenario where you'd have to be really careful with memory allocation. And I thought that was quite an interesting problem. And yeah, I don't see this as being massively difficult, to be honest, because I think you just have to get your head around how to loop over things. But yeah, I haven't completely come up with a solution or anything. I've literally, stumbled over this a minute ago, and I thought it'd be an interesting problem. So let's get going. So one thing to notice, or one thing that I noticed, is that there's a subtle difference between how we would work with an odd numbered grid, so a grid with an edge of a length that's an odd number, versus that of one that has an even number, because here we don't have a center, whereas here we do have a center. So I think that may give some nuances to how we want to deal with the problem. But looking at this example, yeah, I think it's reasonable. So what I was thinking is you could just consider, if you consider a corner item, this 15, for instance. Yeah, sorry, this 5. The transformation would be to move it to this corner. But in order to do that without holding a grid, you effectively have to do every corner in order to complete that transaction. You can't just handle one number. You have to do the corresponding location everywhere. So I think it would be good to create a general purpose function for handling that. To say, given this position, transform the grid by rotating that single cell. So I think that would be a good place to start. And then the problem becomes, well, how do we iterate over the cells that we need to transform? And you'd only have to iterate over one quadrant and say, okay, this one, this one, this one, this one. Pass those into our function, those positions, and assuming our function works, it would perform the transformation, and the problem would be solved, I think. So yeah, I think that's a pretty good approach. So let's create the function. Function transform. Oh, let's go rotate cell. And what we'll do is we'll have the matrix. Let's copy that. And we'll have an X as a number and a Y as a number. And this function will transform it essentially. So, and this is where it gets mathematically interesting actually. I'm just trying to think. So if we had this cell the rotation would have to take us to this cell. So if we have, I guess that would be an index of 0, 0. Sorry, no, it would be 0, 1, 0, 1. Then it would have to become 1, 3. Let's open Excel. Start your free trial. Oh, really? Oh, that's annoying. Oh, okay, that's a bit frustrating, but I can't actually edit anything, can I? Oh, I can. Oh, good. So if we have a grid then, let's just say 1, 2, 3, 4, 5. We'll call that our grid. 0, 0. So let's just say we had 2 here. We want it to go here. Zero, 1, 2, 3, 4, 4. 0, 1, 2, 3, 4. So we have 0, 1 becomes 1, 4 becomes. Oh, okay. This is interesting because let's not confuse the issue. Let's go x, 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 x. So that's the transformation. So this is interesting because I think the opposite is in many ways easier than this 90-degree rotation, because you're always going to be, the maximum number minus the number that you're on. So we're 3 here. So we're 1 across from this edge. When we're rotated 180 degrees, that means we'll be 1 across from this edge. So that's easy to do, to calculate this one. And the row, similarly, if you were here, let's just say y and y, you'd be 1 across and 1 down. Here you're still 1 across and 1 down. So that's cool. But yeah, calculating this one, I guess actually it's not that. If you think of it in terms of deflection from the corner, you're 1 across and 0 down. So here you're 1 across and 0 down. So yeah, if you think about it in terms of being relative to this corner, let's zoom in. Yeah, so if you think about x in terms of the position, it is relative to this top left corner. It's 1 across, 0 down. And you can apply the same principle here. It's 1 across, 0 down, but rotated. 1 across, 0 down, 1 across, 0 down. So that, I think, gives us the way that we can solve this problem, I think. So given a number, x and y, first of all, I think we need the length. So we'll go edge len equals number. Now this should just be number.length, I think. 0, 1, 2, 3. Length is 4. So that's fine. Edge length. So I think we can just, if I'm right, I think we can just assign this matrix directly. I think what we're going to need is to store the original value. Yeah, otherwise we'll lose something. So we need to go const original value equals, and we'll do number x y. So that stores the original value in that location. And now I think we just need to assign the values. So we're going to overwrite this now. And we're going to overwrite, let's just for argument's sake, think of this top left corner again. So we'll assume 0, 0. So in this situation, what we want to do is overwrite with the value contained here. So yeah, I think this is fine. So what we can do is say, well, we need to specify this corner in terms of x and y, but relative to the y coordinate. So yeah, so let's think of 1 actually. That makes it a bit easier because you've got a deflection. So you've got 1 here, so that would be 0, 1, x. Do you know what I need to sort of think about? Yeah, so these rows, x is actually the second array. Yeah, it's actually y, x. I think the way this array is structured. We can just test it actually. Let's, so I think this will be the input. If we say console log number, and we'll go 0, 1, just to output that value, just to see what we get. Oops, matrix, my bad. Yeah, so stood out is 2. Yes, so the x is actually the second thing, so it's kind of row, column. Okay, that's a good important clarification. So we've got, in fact, let's change it to row and column. Oops. Row and column. So row and column. Row and column. So this row and column or this one, let's say, would equal the maximum y value. So that would be edge len minus the column. So I'm using the edge length of 4. In fact, it would be edge length minus 1, because it would be 0, 1, 2, 3. So the edge length is 4. So to get to this position, it would be 3. And then the column is a deflection of 1. So we deduct by that column value, which is 1, to get the row. I think that makes sense. And then here, getting the column becomes, well, for argument's sake, well, we have no deflection here, so we're at 0. So maybe let's use this 4 as an example. So we're currently in row 1. Therefore, we need to actually use the column. So yeah, let's do 2 actually. So if we're 2, we're in row index 1. So we need to actually take this 14, which is in column index 1. So I think what we can do is just use the row index here. Yeah, and I think that works. Next, we need to assign this now. So assuming this reference is correct, we now need to do something else to fill that value. Because yeah, we've just taken the value with this line of code, we've just taken the value in this cell and applied it to this one. Now we need to take the value of this cell and fill it in this one that we've just used to overwrite this value. So now we need to calculate how to get to here. Now I've got a hunch that it's going to be something like edge length minus 1 minus the row. So if we're here, yeah, we're basically saying this is 0, we're over 1 cell. And if we're talking about 12, for instance, as replacing, yeah, sort of relative to here, we want to be relative to this edge. So it's edge length minus 1 minus the row, and also for the column it works the same. And now often with this stuff there's a pattern, and I've got a hunch that this is likely to be very similar to what we need. In fact, I would hazard a guess that it would be this. So this is getting this value. So if we consider 5 and we're trying to get here relative to this 5, how do we get this value? So instead of row, we use the column. In fact, I would say the row, yeah, that makes sense. So if we think about 1, currently that would be row 1, but if we're trying to get to 10, that would be column 1. So that makes sense that we would use the column reference as the row reference here, because if we're in 1, we would end up being row 1. And as for the column, this would be edge length minus 1, so that would be 3, which would be this column, minus the row, which makes sense because if we were row 2, we would want to come in by however many rows down we are. So I think that adds up. So now the final step would be to overwrite this value with the value that we stored earlier. And let's just put some semicolons. And I think that is now a function that will rotate a cell. So when we call this with a given row and column, so say 0, 0, just for argument's sake, when we've got 0, 0, we store it first, then we overwrite the value of 0, 0 with the value of edge length, which is 4 minus 1, which is 3, minus 0. So row 3, which is this row, row 3, and then the column will be the original row, so 0. So that's correct. We will then overwrite this value with this value, which will be edge length minus 1 minus 0, which is 3, and this is also 3, so that's 3, 3. And then we will overwrite this with this value, which is column 0, which, if you remember, is the row thing. So that's row 0, row 0, and the column is 4 minus 1 minus 0, which is 3. So that's this value. So yeah, we overwrite this value, the 5 with the 15, the 16 with the 15. Sorry, the 16 overwrites the 15, the 11 overwrites the 16, and then we get the original value, which was the 5, which overwrites the 11 again. And yeah, I think because we're doing it in this manner, we're calculating the relative positions of the items, relative to the position of what was passed in. We can actually now just call this rotate cell function on any cell, and it will rotate the 4 corresponding cells. So now the problem we have to solve is what do we iterate over? So I think what we just need to do is iterate over a quadrant. Now, something that occurs to me is what you do with an odd. Well, we just need to make sure that we iterate over the correct block, because if you see, you've got these sections that seem to sort of correspond with each other. So if you rotate those, So if you iterate over these, call our function for each of these, that should actually solve the problem. So yeah, I think we're good. We just need to make sure that we iterate properly. The only other thing is if we have an even number, what do we do then? Yeah, what do we do then? So it's essentially the same, except for an odd number, we just have this extra little bit here and we completely ignore the center. So I think we can do this, no problem. So again, I think we need the edge length, kind of crucial. And in terms of iterating, we're going to need 2 loops. Let row equal 0. Now then, let's think. Const rows equals edge len divided by 2. Now, let's go back to our diagram. So the number of rows we need to iterate over, given a length of 5, is 2. So when we divide by 2, we need to truncate the decimal point, because 5 divided by 2 is 2.5. 2.5. Oh, that's not showing as 2.5, but 2.5. Therefore, we need to just round down. So we can do math.floor, and this gives us the number of rows we need to iterate over. Let's row equals 0. Row is less than rows, and we do row plus plus. So that's going to iterate over the rows that we need. And now we need to do the same thing, but for columns. I'm already kind of thinking what this is likely to need. I'm thinking this is going to need this function. Have I spelt that right? Yeah, that's fine. Because the difference is, with the number of columns, we're going to round up. Because for 5, length of 5, we're going to have 3. Now, the brilliant thing with this is this rather elegantly handles the case of an even number as well. So 4, length of 4 divided by 2 equals 2, which if you take the floor of 2 is 2. Similarly, if you take the ceiling of 2, it's also 2. So I think this solves the issue. So now we just need to make sure that we iterate over it. And we'll say col equals 0. Col is less than cols. Col. And we'll call rotate cell. And we will pass in the matrix, the row, and the col. And in theory, this should do it. Let's try. Let's run the code. Wow, first time. That's amazing. I'm even impressed myself. So I did quite thoroughly check it, to be fair. So now we'll submit it and see if that catches all of the cases, the possibilities. And if it does, then fantastic. Look at that. So yeah, I'm pretty pleased with that. Excellent. reasonably fast, and yeah, that's a good solution. So yeah, if you enjoyed watching this, then if you found it educational or just enjoyable, then I would really appreciate if you subscribed. So I'm the Random Coder, and that's it for today. Thank you.